A is having a weight of 80 kg and B is having a weight of 20 kg. It is connected to a thread and move along a rough horizontal plane, and the force you applied is around 400 Newton for this, as shown in the figure. So figure is given. The coefficient of friction is given, which is zero point 0.3. So the contact of these two, you have a coefficient of friction, which is zero point 0.3. Determine the acceleration of the body, right? And tension in thread using D'Alembert's principle. They specifically given to solve by using D'Alembert's principle, but I am going to solve in all the three. Okay, so there is the problem, right? The first step is I have to draw a free body diagram, identify what are the forces. After that, I'm going to resolve it. If you have an inclined force, then you make sigma fx0, sigma fy0. When you do that, you include the dynamic equilibrium condition, right? And you solve it. Okay, right. So let me consider first object. So figure A. So that is block A. So block A is having, it is of a rectangular size, right? So you have a weight, right? So the weight is 80 kg. So when I convert it, so what will be your force? Okay, 784.8 Newton. So this is my force which is acting. And what are the other three forces which is acting? 400 Newton, and it is attached to a string, right? So the string force are always outwards, tension T. And of course, so since you have a contact here, you have a reaction force RA, or suffix A, right? And if we consider here, right, so the string, so don't look at the string. So the string is connected here and here. Anyway, if you apply this force, what will be the movement of this object? Towards left or towards right for this particular diagram?
Towards left, sir.
Yeah, you have an additional force of 400 Newton, which means this object is moving towards left, right? This is my force. So this is my movement, right? It is moving like this. Okay. So in that case, I'm also included that one. So you have a movement like this, right? Since you have a movement along this direction, your friction force will be in opposite direction. So you have a friction here, FA. This FA is nothing but mu into RA, right? So mu is already known, which is given, which is zero point 0.3. So it is zero point 0.3 RA. So FA is zero point 0.3 into RA, right? Now, according to D'Alembert's principle. So I am going to solve by, so these are the things which is common, right? These are the things which is common for all the three methods. Okay. Now, if I consider D'Alembert's principle, so I'm not going to disturb this. I'm going to copy this and I'm going to put it down for this D'Alembert's principle. Okay. So now we are solving it in D'Alembert's principle. Before that, I will complete the other part also, right? So that will be easy for me. So the next one is you have another block. So block B, right? So this block B is 20 kg. So in that case, what will be the force which is acting? So 20 into 9.81 B.
196.2, sir. 196.2.
196.2 Newton. Okay. So this is 196.2 Newton. And it is connected to the string. It is outward T, right? You have a reaction RB. Of course, this object is also moving along this direction, right? Since the object is also moving, P is also moving along this direction. Your friction force is opposite direction, so FP. So this FP is zero point 0.3 into RB, right? So mu into RB, right? So this is my next term. Okay. So I have diagram for both. So I have for B and I have for A, right? So now we'll proceed with D'Alembert's principle. So when you proceed with D'Alembert's principle, the first thing is the rule. You know that. So you have to take a block which is having minimum unknown force. right? From there only we have to solve it. So which block is having minimum unknown force?
Block A, sir.
Block A.
It's like
B, sir.
Okay, both are same, right? So hope in this case both are same because here also you have two unknowns, which is RA and T. FA is not unknown because you have converted to mu into RA, right? So you have two unknowns, RA into T, RA and T. Here also you have two unknowns, RB into T, right? So you can solve any of this block, it doesn't matter. So it won't affect. Okay, so actually the procedure is you should choose a block which is having minimum unknown force. Okay, so right, so now I'm going to consider this A, block A, right? So already I have a free body diagram, right? So same thing, I'm going to do it. I'm going to copy, I'm going to put it here, right? So now I'm going to include one more force because according to Vidya principle, opposite to the direction of force, opposite to the direction of force, you have mass into acceleration, which is MA into AA, right? So mass of block A and acceleration of block A, right? Mass of block A and acceleration of block A. So what is mass of block A? So mass, you know, is just 80. So we can write this as 80 AA, right? That is my opposite force, right? Now, so what I'm going to do is I'm going to put that, what I can say, this force diagram. Let me consider this force diagram. Let me identify what are the forces we have, right? So we have one force here, right? So which is 100 Newton, right? Acting along this direction, right? So next,
400 meter only, sir. Question.
sorry. So it is 400. So so you have one force here which is 400 Newton. This is 400 Newton. Then RA is upward. So you have RA here, right, which is upward direction. So upward direction. So 784.8, that is downward. So this is downward. So it is 784.8 Newton. And along this direction, you have two forces, T and mu into RA. Sorry, three forces, right? So MA, T, and this. So I'm going to add all this because it's the same parallel force we can add. So T plus zero point 0.3 RA plus 80 AA. So these are my forces, right? Any doubt in this?
No, sir.
Now I can say that it is in dynamic equilibrium. So which means I can equate sigma fx0 and sigma fy0. So always you proceed with sigma fy, right? So surely you will get one solution here. So sigma fy is equal to 0. I'll put sigma fy first, then sigma fx, right? So if I put sigma fy, what I will get? I will get Ra minus this is equal to 0, which means Ra is equal to 784.8 Newton. So I got this, right? Now, sigma fx is 0. We put sigma fx is equal to 0. So what I will get? So T plus zero point 0.3 into RA, I know value, so I'm substituting it, right? 784.8. So plus 80 AA minus 400 is equal to 0 because 400 is in opposite direction, right? So these are the overall term, right? So what you will get? So T plus 80 AA minus what is the other term? So can you add this two?
minus 164.56.
Minus 164.56 is equal to 0, right? Which means I will get T plus 80 AA is equal to 164.56. Equation 1. Complete this part, right? So we completed this block A. So everything in this block A is over, right? Only thing is I have to concentrate on block B now. So I am going to add one more force opposite to your direction of motion, right? So that force is mb into ab. Mb I know. What is my mb? Mb were 20. So mass block B is 20. So 20 ab, right? So again, procedure is same. So these are the two forces we are having, right? So again, I can say that it is in dynamic equilibrium. Sigma Fy is equal to 0. I can equate it. In that case, I will get Rb is equal to 196.2 Newton. Now I can equate sigma Fx is equal to 0. When I equate that, I'll get zero point 0.3 into 196.2 plus 20 AB minus T is equal to 0, right? So which means I can write the equation like this: T minus 20 AB is equal to what is this term?
58.86, sir.
58.86, right? Let me consider this as equation 2. Make sure. So you have A acceleration for block A and acceleration for block B, right? Let us identify what will be the acceleration. So how to do that? So let me consider here. I'm going to move this for 1 mm. If I want to move this block 1 mm, what happens to block B? How much it will move?
Same 1 mm, sir.
Same 1 mm. Very good. So it will move same 1 mm, which means your displacement S is same. Your displacement S is same. If your displacement is same, what about your velocity? ds by dt is your displacement, right? So your velocity will also be same. Similarly, acceleration is also same, right? So you have to identify based on distance. If I move for 1 mm, both will move same 1 mm. In that case, your velocity, acceleration are all same. So what I can do is I can say that your AA is equal to AB, right? Your AA is equal to AB. So now I got two equations. You can easily solve the two equations. The first equation is the second equation, T minus 20 AA is equal to 58.86. So can you solve it and identify what is the value of T and what is your AA?
T80 sir, AA is 1.057.
Sorry, AA 2 point
1.057.
1.057 meter per second square, right? So that's your answer. So hope you identified what is the answer for this particular equation. So they are asking acceleration, both the bodies are same, and tension is also we identified. Right. Okay. So 234. So these are the two datas. Right. We identified. Now what I can do, I can equate it. So I can say sigma fx is not equal to 0. But let us identify what is sigma fx, right? Because work done is based on this one, right? Let us identify what is my sigma fx. If I consider sigma fx, so make sure whenever you consider this principle, work energy method or impulse momentum method, the direction side is always positive, right? The direction side is always positive. In this case, since the block is moving along left side, so this is positive x direction, right? This is positive x. Opposite side is negative, right? So the direction is important here. That direction you have to consider as a positive direction. Okay, in this case, 400 is positive minus TAB. This is negative. So this will be minus TAB, right? So in that case, what I can write? I will write 400 minus TAB, which I don't know, minus FA, which is 235.44, right? So this is not equal to 0, right? So what you will get? 400 minus 235.44?
164.56.
164.56 minus TAB. This is my sigma fx. Okay, so I got this term. So now what I can do, I can identify what is my work done, right? What is my work done? So work done is nothing but sigma fx, right, into displacement. Yes, yes, A. So because I am talking about block A, so which means block A will be moving. So yes, A, right? So which means I can write 164.56 minus TAB into SA. This is my work done. And we consider this as equation 1. The next step is I have to identify energy. What is my energy? Right? Energy, we know that of mv square. So which means VA square, right? Which is equal to of what is the mass of block A? So mass is 80. So of into 80 into VA square, right? Which means I'll get 40 VA square, right? So according to this principle, we say that work done is equal to energy. I can equate this two, right? So what I can get, I'll get 164.56 minus TAB into SA is equal to 40 VA square. Let me consider this as equation 2. Again, the procedure is same. I'm going to identify sigma fx. Before that, sigma fy, I can equate it to 0. If I equate sigma fy is equal to 0, what I'll get? I'll get RB is equal to 196.3. So your RB is equal to 196.2 Newton. So in that case, FP is 0.3 into RB, 58.86 Newton. Okay, so your FB we identified. So both are here known. So now I can say that sigma Fx is not equal to 0, which means let us identify what is sigma Fx. Again, the direction. Which direction? So towards left is positive, right? Similar to here, because your object is moving along this direction. So this is positive. So TAB minus this FB, right? That is the value, right? So TAB is, let me consider as TAB. So TAB minus 58.86, right? This is my force, right? Along your x direction. So in that case, I can identify what is my work done. Sigma Fx into S. So SB now, because we are concentrating on block B. So which means TAB minus 58.86 into SB, right? So this is my work done. Okay. So similarly, energy. So energy you will get half m VB square, right? Half m VB square. So half into what is the block? So your block is 20. 20 into VB square, which is equal to 10 VB square, right? So you are getting 10 VB square. So in that case, what I can say, I can again equate it. So work is equal to energy. So which means TAB minus 58.86 into SB is equal to 10 VB square. So this is my equation 2. Now, you know that there is a relation what we identified. So let me divide 2 and 3, right? So if I divide it, what I will get? Okay. So now what I can do, I can just divide this. So if I divide it, you know that these two are same. SA is equal to SB. Similarly, velocity will also be same, right? VA will be equal to VB, right? There is no difference in these things. Okay. So what I can do, I can simply write the other equation, right? And I can cross multiply. So what happens? So this 0, 0 gets a 4, you will get. So I will write it like this. So 164.56 minus TAB is equal to 4 into TAB minus 58.86. Bring TAB on one side, right? Bring TAB on one side and equate it. So you will get a value. So what will get? So I'll get 5 TAB is equal to, bringing on other side, 164.56 plus 4 into 58.86. So what is your TAB?
80, sir.
80 Newton. So I think we are getting the same answer from Newton's method. Yeah, TAB is 80, right? So we got the same thing. Okay. So we got this value now. So only thing is I have to substitute in any of the equation, right? To identify what will be the relation with respect to that. Okay, I think second equation is easy. So I'm going to consider, sorry, third equation is easy. I'm going to consider the third equation. So what is my third equation? TAB minus 58.86. So which means I TAB minus 58.86 SB is equal to 10 VB square. This is my equation, right? So in this, substitute what is my TAB. So 80 minus 58.86 SB is equal to 10 VB square. So what will get here?
21.14.
So 21.14. So which means SB is equal to 10 divided by 21.14 VB square. What is this? 0.473 VB square. Equation number 4. Right? So any doubt on this?
No, sir.
Yeah. So you already know that your acceleration is same. AA is equal to AB. Right? So no need to identify for AA separately. If you identify acceleration for B, that is enough. You can directly solve it. Now, I have the three equations. In this three equation, which equation is suitable for this? Yeah, very good. So second one is most suitable one because initial velocity is 0. We can make it as 0. It is starting from rest. So final velocity is related with this and we have acceleration also. So we will consider equation 2, which means V square is equal to U square plus 2AS. So substitute it. So same thing, V square is nothing but VB square. U square is 0 plus 2 into AB into SB. SB is what? This value. Let me substitute that. So 0.473 VB square. Right? So what happens? So I'm going to cross multiply now. Right? So AB is equal to VB square divided by 2 into 0.473 VB square. So this 2 gets cancelled. So 1 by 2 into 0.473. What is the value of AB?
1.057.
So you have to get the same value. So 1.057, right? Right. So you get 1.057 meter per second square. So this method is what? Work energy method, right? So the same concept. What I am doing, I'm just equating sigma fx and making as work done. Then identifying what is my energy and proceeding like that, right? So this is my first step. Okay, so we will go for the next method, right? Which is impulse momentum, right? So what is my impulse? Impulse is sigma fx into t, right? Time taken. So time taken for block. So TA means TA, TB means TB, whatever it is, right? And what is momentum? It is mass into velocity, right? Mass into velocity, right? Other things are all same. So we already identified what is sigma fx. I'm not going to repeat it again, right? Sigma fx already தெரியும். இதுதான் apply பண்றோம், right? So let me consider block A. So block A, so we know that. So your value is same, sigma fx equal to this. So I can identify what is impulse now. So time with respect to block A, right? What is momentum? Mass is 80 into VA, right? I can equate this to impulse is equal to momentum. Let me consider this as equation 5. I don't know exactly. Let me consider 5. Okay. So similarly, let us go for proceed with the other equation, right? What is that? Your block B. So same, I'm going to identify what is impulse, what is the value. So TB, right? Momentum, mass is 20, 20 into VB, right? So impulse is equal to momentum, equation 6, right? So time is also same procedure. What I do, I am going to divide this. So I divide 5 by 6. So what I will get, so divided by, so this will be 20 VB and this will be TAB minus 58.86 into TB, right? So same, so I can eliminate these things. Your time is same, your velocity is same, I can neglect it. So again you will get 4. So cross multiplying, same equation. So same thing you can able to see here, right? Same equation, you are getting this 4 divided by whatever it is, right? So in that case I will get the same TAB, no need to derive it again. So I will get TAB is equal to 18, right? Substitute in any one of the equation. Let me consider equation 6. So 80 minus 58.86. Again, we have done that. So 80 minus 58.86 is 21.14. So now I can equate. So 21.14 TB is equal to 21.14 TB is equal to 20 VB. So what is TB then? 0.946 VB. Right? Let me consider equation 7. So now again I have got the 3 equations. Which one we can use? I have T in terms of V. I have T in
First one,
terms of
sir.
first one. Very good. So I can use the first term. So V is equal to U plus AT. Right? So V is equal to U plus AT. So V is VB is equal to U is 0 plus AB into T is 0.946 VB. Right? So easily equated. I think you will get the same answer. 1.057 per second square. Any doubt? So let me have something like this. There are 2 blocks shown in the figure. having a mass of 20 kg and 10 kg. The coefficient of friction is given, which is 0.25, and the system is released from rest, and block B falls from vertical distance of 1 meter. Okay, what will be the velocity acquired? So they are asking what is the velocity which is applied on this, and what will be the friction and other things. So this is what the question is, right? Okay, so again, in this case, if this block is moving along this direction for 1 mm, what happens to this block? This block will move how many mm? Same. So you have movement of 1 mm. In that case, I can able to say that your displacement in block A is equal to displacement in block B. Velocity in block A is equal to velocity in block B. Similarly, acceleration is also same. If all these things are same, your time is also same. These are all equator. There's no difference. Now, so where you will have friction, whether you will have friction in both the blocks or only in one block.
Only in A.
Yeah, very good. So you will have only in A because A is having contact with the surface. B is just hanging, right? So you don't have any contact for B. So which means you have friction only in A. So don't consider for B. So B is just like that. We can leave it. So directly we can solve that problem. Okay. Right. So let us draw the free body diagram for these things and then we'll proceed one by one. Okay. So when we consider for block A, rectangular block, and if I consider the force, you have a tensile force here, right? You have a tensile force here. So T, what are AB, right? TAB, and weight is acting here, which is 20 kg. So 20 into 9.8, I think 196.2 Newton, right? So the same thing. So and you have reaction, which is RA, and what is the direction of movement for this block? It is hanging here, so which means this block will move along this direction, right? The block will move along this direction. So we'll have friction here, which is Fa. So this Fa is equal to 0.25 Ra, right? Which is given. Okay, so we will identify this, right? So this is for block A. So what about for block B? So if I consider block B, so it is hanging, right? So it is connected to a thread. So which means we'll have TAB in upward direction, and there is a weight which is acting down. So 10 kg, so 10 into 9.81, right? So we'll get 98.1 Newton. Okay, so any other force? Do you have any other force? No, there is no forces in block B. What is the movement of block B? Your block is moving downward, right? So this block is moving downward. So this movement is important in this things because that is the point where you will be consider the direction. That direction will be a positive direction, and that is the point where you can able to implement this friction and your dynamic equilibrium. There is mass into acceleration, right? That will be included only based on this motion, right? That is very important. The first step is you have to identify the movement, right? Idhula force kudukala, you should not think like that. You should not think that there is no force here, right? So because of this hanging, so surely you know that you can imagine. So this will be falling down, right, due to gravity. So you have to consider accordingly, and you have to do that. Okay. So okay, now we will proceed one by one. So we will go for the first method, right? Newton's law. So only one is I am going to have one more additional force, right? That additional force is opposite to this direction. Mass into acceleration. Mass is 20. 20 into A. This is the additional force. Okay, to make this into dynamic equilibrium. So now I can say sigma Fy is equal to 0. I equate sigma Fy is equal to 0. What I will get? I will get Ra is equal to 196.2 Newton. right? So what is your FA then? So 0.25 into 196.2. Okay, now I can say sigma Fy is equal to 0. Right, if I consider sigma Fy is equal to 0, so we Fy we completed fx is equal to 0. So if I do that, what will get? I will get TAB minus 49.05. This is 49.05, right? So 49.05, opposite direction, minus this 20 into AA. This is equal to 0, right? I think no other force, which means I can write as TAB minus 20 acceleration is equal to 49.05. Let me consider this as first equation. When we go for block B, so you can able to see that the direction is downward, so your equilibrium force will be an upward force opposite to the direction, right? So which is mass into acceleration. Mass is 10 into AB, right? That will be acting down upward, right? So now there is no sigma fx here, only Fy. So I can directly equate sigma Fy is equal to 0, right? Which is TAB minus 91.1 plus 10 AB is equal to 0, which means TAB minus, sorry, plus 10 AB is equal to 98.1. Let me consider this as equation 2. So I got these two equations, right? So you know what will be the acceleration. Acceleration is same, right? I can equate it easily. So equation 2, equation 1. So 1 is also same, right? So I will copy this, right? So can you equate and tell me what is the answer for this? Use a calculator, solve this, and find out what is the answer. Tell me what is your TAB. Don't say 81.75. Very good. Yeah, 1.685 meter per second square. I'll go for the next method, work energy method. So if I consider this work energy method, again for block A, I'm going to concentrate. So the thing is, you don't have this force, mass into acceleration force clearly, right? Movement, that is important. Here the movement is along this direction, so this is positive, right? This is positive direction. Okay, so that alone is important. Other things are no need. So Fy same, if I equate, I will get the same thing. I'm equating, I'm getting the same value. So now my aim is to identify sigma Fx. So it is not equal to 0, I'm equating it. So this is positive term, so TAB minus your friction force 49.05. This is my Fx. So in that case, I can identify what is my work done. So work done is TAB minus 49.05 into SA, right? Force into distance, right? That is my work done, right? Next, energy. So here only kinetic energy, which is half mv square, right? So half m. So m is ma. This is also ma va, right? So which is equal to. So what is the weight of this block? 20, right? So which means 10 va square. Right, so I can equate it now. If I equate, I will get TAB minus 49.05 SA is equal to 10 VA square. So let me consider the first equation. Now, let me go for the next block, B. So you don't have this force, right? So now I can say that sigma Fy is not equal to 0 because the direction of movement is along this direction, which means this is a positive direction, right? So what you will get? I'll get sigma Fy is not equal to 0, which means sigma Fy is equal to 98.1 minus TAB. Right, that is my total. So in that case, I will identify what is my work done. Work done is 98.1 minus TAB into SB, right? Similarly, I'll identify energy. So energy is half mv square, half into what is the weight of this block? 10, right? So half into 10 VB square, right? So you can equate it. So what I'll get? I'll get 98.1 minus TAB into ST is equal to 5 VB square, right? So this is second equation. So now I can divide these two equations. So you know that VA, VB all are same. I can equate, I can cancel these things, right? So now I can identify TAB minus 49.05 is equal to, so 10 by 5 is 2, 2 into 98.1 minus TAB. Okay, so this is my fact. So can you identify what is my TAB? Okay, so this is 81.75. Okay, this has to be 81.7. Right, so what is your SP? 0.305. Right, okay. So in that case, this will be 0.305. 0.305. So what is the value? Okay, same value, 1.635. Right, so as like we got in Newton's method. Right, so 685 வருது. So okay, similar to that. Okay, any doubt in this? Okay, can you try out for impulse momentum? You try it out. Okay, next class we will discuss about this problem.